Pull! Oh! Ooh! Yeah! Woohoo!
Mathematics is all around us as we discover more about our environment and our surrounding as well. We see that nature can be described mathematically. The beauty of a flower, the majesty of a tree, and even the rocks upon which we walk can exhibit nature's sense of symmetry. The nature of mathematics can be explicit by analyzing the chief characteristics of mathematics. Mathematics is the discovery of relationship and the expression of those relationships. In symbolic form, in words, in numbers, in letters, by diagrams or graphs. According to A.N. Whitehead, every child should experience the joy of discovery. Mathematics can give an easy and early opportunity to make independent discoveries. Children must have opportunities for making their own discoveries. Mathematics is a science of discovery. Mathematics is an intellectual game. Mathematics is a tool of subject, and mathematics is involved in intuitive method. Math plays an important role in our world. Until now, the formulas that our mathematicians created are being used in school to teach children, to profession, to build buildings, analyze economic data, and to the accounting field. Plays an important role in technologies that we are using today.
Welcome to our lesson on patterns and numbers in the modern world. There are three main types of patterns: symmetry, fractals, and spirals. All of these patterns can be seen all around us, from the shape of the leaves to the structure of galaxies. First is symmetry. Symmetry comes in two forms: bilateral, where an object can be split into mirror images, and radial, where patterns repeats around a central point. Second is fractals. Fractals are complex patterns where each part has the structure as a whole. They're found in natural formations like snowflakes and coastlines.
Spirals. Spirals is another type of pattern seen in nature. From the swirl of the hurricane, the shape of galaxies.
Patterns and regularities. In the modern world, patterns and regularities are found in various domains, from the natural phenomena to human-made systems, and are used to gain insights, make predictions, and optimize decision-making.
Techniques such as machine learning, data analysis, and symmetry analysis are employed to discover and describe patterns in vast amounts of data, revealing hidden structures and relationships that can inform our understanding of the world.
What is the language of mathematics? Mathematics is often referred to as the universal language because it transcends the cultural and linguistic barriers, allowing people from different countries and backgrounds to communicate and understand complex concepts through symbols and equations. In the modern world, the language of mathematics is essential for various fields such as science, engineering, and economics. One of the key reasons why mathematics is important in the modern world is its ability to provide a precise and universal way of describing relationships and patterns. In technology, mathematics is essential for developing algorithms, designing computer systems, and analyzing data.
So, there are some examples of the language in mathematics in the modern world include cytography, data analysis, engineering, and financial modeling. Overall, the language mathematics is an indispensable tool in the modern world, enabling us to understand the complex of phenomena make informed decisions, and drive innovation across various fields.
Alright! Good day, everybody! I am Jane Nunez Basalan, 18 years old. And now, we are talking about the language of Set. Now, the question is, what is language of Set? The language of Set is typically refers to the formal language used to describe and manipulate set and the set of theory. In mathematical logic, set theory is often discussed using formal language that includes symbol, syntax for representing set, membership, and various operations.
Good day, everyone. My name is Ayesha Evsala, and our topic for today is all about the language of relations and functions. Relation is abound in daily life. People are related to each other in many ways, as parents and children, teachers and students, employers and employees, and many others. And business things that are both are related to their cost, and the amount paid is related to the number of things bought. Relation is a rule that relates values from a set of value called the domain to a second set of values called the range. The elements of the domain can be imagined as input to a machine that applies a rule to this input to generate one or more outputs. A relation is also a set of ordered pair x and y. For example, a relation of R have a set of ordered pair 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. The domain is 1, 2, 3, 4, and 5. And the range is 2, 4, 6, 8, and 10. And that is the example.
Today, everyone, I am Elsie Answer to continue about the discussion about function. Function is a relation which each element in the domain is related to only one value in the range by its input. The limits of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. A function is a set of ordered pairs x and y. Such as that no two ordered pairs have the same x value but different only y values. A function can be represented in different ways. 1. A table of values. 2. Ordered pairs. 3. Graph. 4. An equation. And the last one is a vertical line test. A graph represents a function if and only if each vertical line corresponds the graph at most once.
Juliet Piala from PIP Interior Design 1C grade program. Mathematics has always been a tool for problem solving. Math by nature is based on logical and valid reasoning so that it is used for decision. In this lesson, you will learn how to organize your own methods and approaches to mathematical subjects.
There are two types of reasoning, the deductive reasoning and the inductive reasoning. So, what is deductive reasoning? Another type of reasoning is called deductive reasoning. Deductive reasoning is distinguished from inductive reasoning in that it is the process of reaching a conclusion by applying general principles and procedures. For example, all squares are rectangles. All rectangles has 4 angles. Therefore, logic tells that all squares have 4 right angles. Here are the importance of deductive reasoning. It is a powerful tool for logical thinking and problem solving, playing a crucial role in various aspects of our lives.
Inductive reasoning is a type of reasoning that uses specific example to raise a general conclusion. It's called inductive reasoning. The conclusion formed by using inductive reasoning is called conjecture, which may or may not correct. For instance, the following are examples of inductive reasoning. Jenny leaves for school at 7 a.m. Jenny is always on time. Therefore, Jenny assumed that if she leaves for school at 7 a.m., she will always be on time. However, may not be right because Jenny would have still be late even she leave early due to she encounter some unexpected causing to be late. The chair in the living room is red. The chair in the dining room is red. The chair in the bedroom is red. Therefore, all chairs in the house is red. However, may not be correct. There are some other chairs in the house that are not red. Even you examine a list of numbers and predict the next number and the less according to some figure you observe, you are also using inductive reasoning. That's all, and thank you.
Lesson 3 on Polya's problem-solving strategies. Alright, let's start with the first step. Understand the problem. Our problem is, you have 10 apples, but you want to share it equally to your 3 friends. Now, how many apples does each person get? And what are we trying to figure out? How many apples each person will get? For that, let's move on to the next step. Devise a plan. It's time to devise a plan. We know we're sharing the apples equally. So the easiest way to figure things out is by dividing 10 apples by 4 people. Right, because division is all about sharing things equally. So the plan is to divide 10 apples by 4 people. Step 3, carry out a plan. Now we have to carry our plan. We'll divide 10 into 4. Now each person gets 2. Oh no! But wait! 2 times 4 equals 8. We started at 10, but now we have 2 leftovers. Oh my god! What do we do about them? Oh yes! We divide them into halves and give each person half an apple. Perfect! So each person gets 2 apples and half another apple. Step 4, review and look back. Great! Now let's check, does our solution make sense? We divided 10 apples equally and made sure no one was left out. Each person gets 2.5 apples. That uses up all 10 apples. We used division to solve it, and by reviewing, we see that it makes perfect sense.
So let's proceed to my assigned topic, which is the classification and organization of data. So, what is classification and organization of data? Classification and organization of data are essential process in data analysis, enabling us to make sense of raw information and meaningful insight. They involve transforming of data into structured and meaningful formats, allowing for easier analysis, interpretation, and making. Here are some aspects of data classification. First is the classification. First
So, here are some aspects of data classification. First is the categorization. Second is qualitative attribution. And lastly is the levels of classification.
Example, surveys and experiments. Second, data analysis. It has table, chart or graph, and histogram. Presentation, it has table, data or graph, and histogram.
Measurement of central tendency, including mean, median, and mode, are the statistical tools used to summarize data set by identifying central point around data values. The mean provides the average, and the median gives the middle of the order of the other data. And lastly, the mode. The mode has the most frequent occurring data value.
Hi everyone, go there.
Measure of the earth. A measure of variability is a set of data of a number that conveys the idea of spread of a data set. The common measure of the earth is range, variance, and standard deviation.
Range. The range is the difference between the largest and the smallest values in dataset. It's like the distance between the two extremes.
Variance. Variance is a given set of a square of the standard deviation of data.
Standard deviation. The standard deviation is a measure of how spread and numbers are. The symbol is the Greek letter sigma.
Hey everyone, my name is Anna May Kawelan, and our topic for today is measure of relative position. A measure of relative position in statistics indicates the location of data value relative to the rest of the data set. It helps determine how a specific value compares to others within the data set, either by ranking or standardization. Here's some common measures of relative possession.
So before we continue, let me introduce myself. My name is Michelle Odovbar, 18 years old. So let's continue. 3. Z-score, standard score. The Z-score tells how many standard deviation a data point is from the mean of the dataset. It is a standardized measure. Here's the formula. Z-score, X, the data point, the mean of the dataset, and the standard deviation of the dataset. Interpretation. Z, 0 means the value is at the mean. Positive z-score indicate values above the mean, and negative z-score indicate values below the mean. Decels. Similar to percentiles, decel divide data into 10 equal parts. D1, the value below which 10% of the data falls, and the D9, the value below which 90% of the data falls. 5. Ranks. Ranking orders data from the highest to lowest or vice versa. The position or rank of the value relative to others can also be considered a measure of relative position. So, that's the 5 common measure of relative position. The measure help you understand how individual data points compare with others, providing insight into distribution, trends, and outline. 5. Ranks. Ranking orders data the highest to lowest or vice versa. The position or a rank of a value relative to others can also be considered a measure of relative position. So, that's the 5 common measure of relative position. This measure helps you understand how individual data points compare with others, providing insight and distribution trends and outliers.
Good evening everyone. For tonight's video where I am going to introduce myself first, I am Paslon Kizel and my topic is normal distribution. What is it and how do we interpret it? chances are you've been seeing a normal and Gaussian distribution before. It is called a bell-shaped curve because it is a symmetrical curve that looks like a bell. In this example, the curve here, the curve represents human height measurement. People can be short, people can be average height, or maybe tall, or anywhere in between the y-axis. The y-axis represents the relative probability of observing someone who is really short or really tall or has an average height. For example, in the short, relatively rare to see someone who is super short, so the bell-shaped curve is relatively in the part of the graph, but it's quite common to see someone who is close to the average height, so the bell-shaped curve is very tall. Take a look at this in example, and in this region it's relatively rare to see someone who is really tall. So again, the bell-shaped curve is relatively low in this region. The two normal distributions of the height of male human when they're born and adults. This is the distributions for the baby, and this is the distribution for adults here. And the average baby height is 20 inches or 20 inches like this. And then this is the adult height, 70 inches. Normal distributions are always centered in the average value. In this part, this is the centered average value here. By looking at the graph, we can tell that this is this high probability that a newborn baby will be between 19 or 21 inches tall. In contrast, adults are between the 60 or the 70 inches tall. You may have noticed that the curve for babies is weight compared to the curve for adults. It is because there are many more possibilities for adults' height than for babies. The more options there are for height, the less likely any specific measurement will be one of them. And the width of the curve determines how tall it is. The wider the curves, the shorter. The narrower the curve, the taller. Here's the normal distribution to draw. How to draw a normal distribution you need to know. Number 1 is the measurement. This tells you where the center of the curves goes. Number 2, the standard deviations of the measurement. This tells you how wide the curve should be. The normal distribution is kind of magical in that we see it in a lot in nature, but there are reasons for that, and that reason makes it super useful for statistics as well.
I'm Maria Dorothy G. Rujas, and I will going to present to you the correlation. Correlation is a statistical measure that describes the relationship between two variables. It indicates the extent to which changes in one variable are associated with changes in another variables. Correlation range from -1 to +1, where a correlation of 1 indicates a perfect positive relationship. A correlation of -1 indicates a perfect negative relationship, and a correlation of 0 indicates no relationship between the variables. Correlation is commonly used to analyze the strength and direction of a relationship in a data set. There are 3 main types of correlation: positive correlation, negative correlation, and zero correlation.
Learner, prediction, but most real-world Problems have many components. In such a case, we would want to use the expression of linear regression.
Called multiple regression, this is another pragmatic regression method, and since it's pragmatic, it also has a general from y is equal to f of p plus exponent, but this time if of x takes the form of the sum of product of p convenes and configuration that is beta of plus beta 1 times 1 plus beta 2 times 2 of the way up to beta p times p. So the immediate value of the responding variable y is given by this equation.
Simple interest is calculated by multiplying the principal, the amount of money that is initially invested or borrowed, by the rate, the speed at which the interest grows, and the time how long money is being invested or borrowed. In other words, the formula for simple interest is I equal PRT.
Hello everyone, my name is Pipian Habib. I'm here to explain different topics including math concepts like simple interest. Today we'll discuss about simple interest. What is simple interest? Simple interest is the fixed percentage of total amount invested paid to investor each year for the total duration T the money is invested. I is the interest earned or paid. P is the principal, is total amount invested. Makita natin na malaking amount sa problem. R is the interest rate as the decimal, and T is the time of money is borrowed invested. Here the example of simple interest.
Maria deposited 20,000 a bank that gives 10% simple interest. How much interest she will receive after 3 years? Ibig sabihin sa deposit, this original amount. Usually naman, meron kayong nakita na malaking this a principal. Be careful, minsan yung interest. The given P equal 20,000. So, ang rate, 10% divided by 100. This answer, the rate is 0.10. And then, solution is, gagamitin natin na formula is I equal PRT. So, percentage is 20,000. Ang rate is 0.10 and time is 3. So, P times R times time. So, ikuan na to, i-times ato ang 20,000 times 10, 0.10 times 3. So, kapag na ay parenthesis, i-times na natin, i-calculate natin sa calculator. So, 20,000 times 0.10 times 3. That is the answer is 6,000.
Compound interest is the interest on an investment or loan that is calculated based on both the initial principal and the accumulated interest from previous periods. It grows more rapidly than simple interest because it compounds over time. Here's what each part means. A is the amount of money you'll have in the end. P is the principal amount or initial money you start with. R is the annual interest rate or as a decimal, so 5% becomes 0.05. N is the number of times interest and compounded per year, like monthly or annually. T is the number of years the money is invested or borrowed for. Use this formula. First, convert the interest rate from a percentage to a decimal. Second, divide the annual interest rate by the number of times interest compound per year. Third, add 1 to this number. Fourth, raise the result of the power of the total number of compounding periods or number of times interest is compounded per year multiplied by the number of year. And fifth, multiply the result by the principal amount to get the final amount.
For example, if you interest $1,000 at an annual interest rate of 5% compounded monthly for 2 years. Number 1. Convert 5% to 0.05. Number 2. Divide 0.05 by 12 compounded monthly, which gives 0.00416. Number 3. Add 1 to get 1.004167. Number 4. Raise 1.004167 to the power of 24. So, 12 months times 2 years, which is about 1.083282. Number 5. Multiply this by 1,000 to get $1,083.28. So, after 2 years, you would have $1,083.28. That's it.
A stock, also known as equity, is a security that represents the ownership of a fraction of the issuing corporation. Units of stock are called shares, which entitle the owner to a proportion of the corporation's assets and profits equal to how much stock they own. A bond is simply a loan taken out by a company. Instead of going to a bank, the company gets the money from investors who buy its bonds. In exchange for the capital, the company pays an interest coupon, which is the annual interest rate paid on a bond expressed as a percentage of the face value.
Hello, my name is Hannah Espillarga.
And I am Leia Dilema.
In this video, we'll explore key concepts and problems that show just how fascinating and useful math can be. Now, what is a graph? A graph is a set of points called vertices and line segments or curves called edges that connect vertices. Now, here's the example of a graph. As what you can see, this is what we call, this line segments is called a vertices. And here, this line segments is called an edges. Look closely. The other example of a graph, it can be curves, but still, it can be called as an edges. Now, here's the other examples of a graph. As you can see, this is the first example. This is a graph that connected and has a pair of multiple edges. And the second one is, this graph is not connected. It consists of two different sections. It also has a loop. Here is the loop. Now, the third one is, this is a complete graph with 5 vertices. Now, as you can see, 1, 2, 3, 4, 5. Now, here's the other example of equivalent graph. First one is this. As you can see, the letter is in the center. And letter E is connected to the line segment letter C, letter D, E to B, E to A. Now here's the other example also. The letter E is also in the center. Letter E line segment connects to letter C, letter D, letter B, and letter A. So what is Euler circuit? Euler circuit is a circuit that begins and ends at the same vertex and uses every edge but never uses the same edge twice. There are some terminology in Euler circuit. First, we have path. A path in a graph can be thought of as a movement from one vertex to another by traversing edges. Example, this one. We can refer to our movement by vertex letters. One path would be A to B to C. So that is considered a path. Second one is closed path or circuit. Closed path or circuit is a path ends at the same vertex at which it started. For this graph, the path is A to D to F to G to E to B and to A is a closed path since we started with A and we also ended at A. So in Euler circuit, we must use all the edges, but we can use it once. From explaining graphs to equivalent graphs and Euler circuit, this video aims to make math both clear and interesting. Thank you for watching.
What is weighted graph? A weighted graph or a network, the weight is assigned to each edge. Such weights might represent, for example, cost, lengths, or capacities, depending on the problem at hand. A weighted graph is a graph in which vertices, edges, or both vertices and edges are assigned numerical values known as weight.
In a weighted graph, finding the shortest path between two nodes takes into account the weights of the edges, which can lead to more accurate results. This is particularly useful in applications where finding the optimal path is critical, such as in logistic or transportation planning. So we're gonna show you the example of the weighted graphs above.
Euler's formula, named after Leonhard Euler, is a mathematical formula in complex analysis that established the fundamental relationship between the trigonometric function and a complex exponential function. Euler's formula states that for any real number x, one has
where e is the base of natural logarithm. I is the imaginary unit and cos and sine are the trigonometric function cosine and sine respectively. This complex exponential function is sometimes denoted as x cosine plus I sine.
Hello and good day to everyone. I am Juvin Abragas.
I'm Eliza Isatang from IDT1C. In today's video, we will be discussing Unit 6, the mathematics of graphs. Listen for graph coloring.
What is graph coloring? Graph coloring is a method of assigning colors to the vertices or nodes of a graph such that no two adjacent vertices share the same color. This concept plays a crucial role in graph theory and has several real-world applications. In simple terms, if you imagine a graph as a network of points or vertices connected by lines or edges, the goal is to assign different colors to connected points. The rule is that no two points directly connected by a line should have the same color. Graph coloring has many important applications in real life. Scheduling and resource allocation, for example, assigning time slots to university exams without scheduling conflicts or allocating radio frequencies without interference. Optimization problems. Graph coloring helps solve problems where the goal is to use the fewest possible resources, such as finding the minimum number of color for a graph. Theoretical computer science. It is used in algorithm complexity analysis, providing insights into how difficult certain computational problems are to solve. Social network analysis. Graph coloring helps identify communities or groups in social networks. Graph coloring offers efficient solution to many optimization problems such as scheduling tasks, managing resources, and analyzing networks. It simplifies complex system by using minimal resources while avoiding complex or overlaps. The three basic rules of graph coloring are: assign colors to vertices. Each vertex must have a color. No adjacent vertices can have the same color. Vertices connected by an edge must have different colors. Use the minimum number of colors. The goal is to color the entire graph using as few colors as possible. These rules ensure that graph coloring is efficient and valid. The third rule pushes for optimization, which is central to graph theory and its applications. Not every vertex must have a unique color. Only connected vertices need different colors.
The maximum number of colors needed for a graph equals the number of its vertices, but typically fewer colors are required based on the graph structures. In this example, the minimum number of colors needed to color the vertices according to the rules of graph coloring is 5, with each vertex having its own color. This process of graph coloring demonstrates how each vertex must be assigned a color different from its connected neighbors, ensuring no adjacent vertices share the same color. In this case, each vertex ended up with a unique color because of the structure of the graph. The chromatic number is a critical measure of a graph's complexity in terms of coloring. The fewer the colors required, the simpler the graph is to color. Finding the chromatic number is a challenging problem in many cases and is central to many optimization algorithms in graph theory. This application highlights how graph coloring is applied to a wide range of fields, from university scheduling to network management and logistics. In each case, the goal is to solve problems efficiently by minimizing conflicts and optimizing resources.
That's the end of our discussion. We hope you learned something and understood the topic. Thank you for watching and listening. Always remember, graph coloring is more than just a mathematical study. It helps us solve complex real-world problems by minimizing conflict through efficient coloring solutions.
Lesson 1. Logic Statement. Logic is the study of principles of correct reasoning. The term logic came from the Greek word means logos, which is sometimes translated as sentence discourse, reason, rule, and ratio. It is often used quantifiers to specify the scope of assertion about the element in a set of domain. Quantifiers help to formalize statements and make precise claims. A logical statement or proposition is a declarative sentence that is either true or false, but not both. For example, statement 1. 5 is an odd number. This statement is true. Statement 2. 7 is less than 5. This statement is false. In addition, understanding and using this logical statement or quantifiers allow mathematicians to formulate precise definitions, theorems, and proofs.
Quantifiers are used to express statements about elements within a domain. It helps define the scope and applicability of logic statement. There are two elements of quantifiers. First, universal quantifiers, used to state that a particular property or condition holds for all elements in given domain. Second, existential quantifiers, used to state there is at least one element in the domain for which a particular property or conditions hold.
Good evening, everyone. I am Chrislyn James Dibutak, and the topic is all about truth tables and tautologies. So let's start defining truth table. Is mathematical table used to determine if a compound statement is true or false. In a truth table, each statement is typically presented by a letter or variable like PAR in each statement. Also has own corresponding column in a truth table that lists all the purpose truth values.
Hello everyone, I am Hanan Bunday. So now I'll discuss you about truth tables and tautologies. What is truth tables and tautologies? Let's start defining truth tables is a mathematical table used to determine if a compound statement is true or false. In a truth table, each statement is typically represented by a letter or variable like P, Q, R. In each statement also has own corresponding column. In a truth table that lists all the possible truth values. So now, I'll discuss you the term or operations that we use to determine if a compound statement is true or false using a table. First is number 1, negation. Opposite truth value from the statement. So, number 2, conjunction. Only true when both statements are true. Number 3, disjunction. Only false when both statements are false. P implies Q, also known as if-then result true in all cases except the case P implies F. Number 5, logical equality, also known as the biconditional or if and only if symbolically arrow both sides. Only true if the both statements are true and even both statements are both false will result to true. Thank you.
Hi everyone, my name is Marian Hidden and I want to discuss conditional statement. Conditional statement can be written if P then Q form or in if P Q form for all if the following are conditional statement. In any conditional statement represent if P then Q or by if P Q then Q statement is called antecedent and the Q is called consequent.
A biconditional statement means that two things are true or false together. It's like saying P if and only if Q, which means both P and Q must happen together. For example, it is raining if and only if the ground is wet. This means the ground is wet exactly when it's raining and not otherwise. It sets up a rule where both parts depend on each other being true or false at the same time.